Hello students, welcome to Manzy tutorials. So in the last two or three videos, we will be learning about laws of exponents. The first video was understanding all the 8 laws of exponents. The second video was doing around 14 to 15 practice problems. And in the third video, we showed that how we can prove a power 0 is equal to 1 by using the other laws of exponents. And now, as we know that we are actually following the paper from the questionnaire from Coursera software, we are going to follow the same questionnaire. And as you know that there are 30 questions in that, and have solved only the 14 questions. In this video, we are going to complete the rest of the questions. So let me open up the document. So we'll see question number 15. It says 3k power 4 whole power 4. Question number 15 is 3k power 4 whole raised to the power 4. The form that we are going to use here is going to be a power m whole power n is equal to a, guys. So we are definitely going to use this formula a power m times n, but we also have another formula that is going to use first a power m a b power m is equal to a power m dot b power m, or multiplied by b power m. So this is the first formula that I'm used on this expression or on this term. So the 4 is going to be distributed over 3 and also k power 4. So it becomes 3 power 4, then k power 4 whole power 4. So 3 power 4 is nothing but 3 multiplied by 3 multiplied by 3 multiplied by 3 4 times. Excuse me, guys. And k power 4 whole power 4 is nothing but a power m whole power n gives you a power m multiplied by n, becomes k power 4 multiplied by 4. So here you know that 3 times 3 is 9, 3 times 3 is 9 times 9 is 81. 81 k power 4 times 4 is 16. So this would be your final answer. Let me go to the question number 16. In question number 16, you have 4xy whole raised to the power of -1. 4xy whole raised to the power of -1. So now you know for a fact the formula. Let me write all the formulas in orange color. A power -n is equal to 1 by a power n. To simplify this, all we have to do is take this particular term and put it in the denominator and make it positive, and you know that any number raised to the power of 1 is always the number itself. So it comes to be 4xy. So this is your final answer. Very simple. 17th one. You have 2b power 4. This is a whole power raised to the power -1. 2b power 4 whole thing is raised to the power negative. We are going to use the exact same formula, and it's going to become 2b power 4. So I'm going to take the next formula. It is x square y power -1 whole square. Let me make this a little bigger so you guys can see the questions. X square y power -1 whole square. I'm going to write question number 18 over here. And then x square y power negative 1 whole square. Now here we are going to use two or more formulae. So the first formula that we need to use is ab whole power m is equal to a power m multiplied by b power m. What we are doing is we are taking this m value and distributing it over a and distributing it over b. The same thing we need to do, take two value, distribute over x square and distribute over y power negative 1. When I distribute it, it becomes x square whole square y power negative 1 whole square. All I'm doing is taking this term and distributing it to the two terms that I have over here. Now, what's going to happen is, you know that a power m whole power n is equal to a power m times n. If you have a power like this, which is raised to another power, all you have to do is multiply those two powers, leaving us to multiply 2 times 2, negative 1 times 2. So let's multiply this. I'm going to get x2, I mean x power 2 multiplied by 2. Same thing with y power negative 1 multiplied by 2. So x square, x power 2 multiplied by 2 is nothing but x power 4. Y power negative 1 multiplied by 2 is y power negative 2. But you know also another formula, a power negative n is equal to 1 by a power n. So this is going to give you x power 4. So this negative 2, whatever is here, I can take this to the denominator and make it positive. This is how you solve problem number 18. It's a very interesting problem and simple as well. But here, I want you to notice, to actually simplify this term, we have been using three different formulae to solve that and to simplify that and to get to the most simplified form, right? So that's how some of the problems work, like where you have to actually focus on using three or more formulae to actually get the answer. Okay, and that's with practice, and that's the reason we are going to do a few more problems of similar type, and then I'm pretty sure that you all will be thorough with this concept. But practice is only going to help you to learn this stuff. Now let us see question number 19. Here you have 2 x power 4 y power negative 3 raised to the power of negative 1. 2 x power 4 y power negative 3 whole raised to the power negative 1. You can do it two ways, but to do the easiest way first. So let me show you the method 1 for this. You know that let me write the formulas in orange color. AB whole power m is nothing but a power m b power m. That means I'm going to take this negative 1, distribute it over 2, distribute it over x, and distribute it over y. So it becomes 2 power negative 1, 2 power negative 1, x power 4 whole power negative 1, y power negative 3 whole power negative 1. And then what happens with a power negative n? But 1 by a power n. That makes 2 power negative 1 as 1 by 2. And when you multiply a power m whole power n is equal to a power m times n. That's going to give you x power 4 times negative 1 and power negative 3 times negative 1. So the final answer is going to be x power 4 times negative 1 is negative 4. Y negative 3 times negative 1 is going to give you positive 3. So leave the positive 3 in the numerator, but you know that x power negative 4 can be pulled down to the denominator, and it's going to be 2x power 4. And when 1 is multiplied by y power 3, it's going to be y cube. So this is this most simplified question answer this question. But again, if you notice the things in the orange, I'm using 3 different formulas to solve one problem. So when the complexity increases in solving these kind of problems, you will have to use more than 3 or 4 formulae at once. And that's the reason you need to know all the laws of exponents by yourself. And having said that, it comes only with practice. 3m power negative 2. Very simple problem again. 3m power negative 2. You can simply take the power and put it in the denominator because it has a negative its exponent. So it becomes 3m whole square. But still, you know that you can distribute this 2 to 3 and 2m in the denominator. And then it's going to become 3 square m square. And you know that 3 square is nothing but 9. 1/9m square would be your final answer. R square by 2r cube. Interesting. R square by 2r cube. So nothing but 2 is going to remain like that. 1 by 2 r square by r cube. You know that second formula, you know that a power m divided by a power n is equal to a power m minus n. Okay, my bad, I should have written this in orange, but I'm going to just highlight this. We're going to use this formula, and now it becomes 1 by 2 r power 2 minus 3, which is going to result in 1 by 2 r power negative 1. But you know that any number raised to the power of negative power is nothing but you can make the power positive by moving it to the denominator. So it's going to be 1 by 2 multiplied by 1 by r power 1. But you know that any number raised to the power of 1 is the number itself. So it becomes 1 by 2 r, because you can multiply the denominators and finally you're going to get the same answer. So the simplified form of r square 2r divided by 2r cube is nothing but 1 by 2r. And here also we are using 2 different formulae. Okay. Let me draw a line, and I'll be posting this class notes as well in the as a link in the description. So that's from my Google Drive. So you guys are free to download that, download the class notes and refer later. (22) x power negative 1 divided by 4x power 4. Oh, that's 22. Yeah. X power negative 1 divided by 4x power 4. So here, either you can take this x power negative 4 to the numerator, it becomes x power negative, x power 4 becomes x power negative 4, or you can take this numerator term, pull it to the denominator and becomes positive. So either ways you can do it. So to make it simplified, what I'm going to do is I'm going to first let us write the formula that we are going to use. A power negative n is equal to 1 by a power. Using this formula, I can write it as 1 by 4x power 4 remains the same, but this numerator, which is in green, which is highlighted in the color, is going to become the denominator with a positive exponent, and the positive exponent is nothing but 1. So now you're going to combine these two and then write 1 by 4. In the denominator, you have x power 4 multiply x power 1. And you know that irrespective whether the terms are numerator or denominator, a power m multiplied by a power n is equal to a power m plus n. So that becomes 1 by 4 x power 4 plus 1, that is 1 by x power 5 with 4 as its constant. This will be your final answer. This is 22. We do have problems. Let me do that as well. 23. 3n power 4 divided by 3n cube. Again, a simple problem. 3n power 4 divided by 3n cube. In a problem like this, first you see the constants. Since the constants are equal, you can simply strike them off and let us write what is remaining, n power 4 divided by n power 3. Again, it is very simple because you know the formula a power m divided by a power n is equal to a power m minus n. All you have to do is subtract the powers and you're going to get 1. 25. Oh, I think you have 24. M power 4 divided by 1 divided by 2 m power 4. M power 4 divided by 2 m power 4. So now I'm going to split this and multiply and divide m power 4 by m power 4. You know that if the numerator and denominator are same, you can simply strike them off and the remaining answer would be 1 by 2. Another method to do this, instead of striking it off, some people what they do is they write 1 by m power 4 minus 4. That will be resulting in 1 by 2 m power 0, and any number raised to the power of 0 is 1. You get 1, and when you multiply half with 1, you're still going to get the same answer. It's totally up to you. You can choose either of these methods to actually solve. So this is method 1. This is method 2. It's totally up to you. You can choose anything that you want. I personally prefer this because less number of steps in it. Perfect. So we have almost 25. There are 5 more problems that are remaining. So this is 2x power 4, y power negative 4, z power negative 3. Let me write down the numerator first. 2x power 4, y power negative 4, z power negative 3. Divided by 3x square, y power negative 3, z power 4. Divided by 3x square, y power negative 3, z power 4. So to solve this problem, we have to differentiate, we have to bifurcate all the x terms, y terms, and z terms separately. So I'm going to write the same equation, but in a much different fashion. 2 over 3 is multiplied with x over 4 divided by x square. This makes my work very simple to solve these kind of problems for negative 4, y power negative 3, z power negative 3 divided by z power 4. So the first formula that we are going to use is a power m divided by a power n is equal to a power m minus n. So while using this formula, 2 over 3 remains the same. 2 over 3 x power 4 divided by x square will give you x power 4 minus 2. Same thing with y power. Y power negative 4 minus negative 3, because you have to take minus as per the formula over here, but you have a negative n over here, that is going to remain the same. Same thing with z. Z becomes negative 3 minus 4. 2 over 3. X power 4 minus 2 is x square. Y power negative 4 minus of minus becomes plus. Y power negative 4 plus 3, and z power negative 3 minus 4. Now simplifying this, you're going to get x square. Y power minus 4 plus 3 is y power minus 1, and z power negative 3 minus 4 is z power negative 7. Now we are going to use another formula. A power negative n is equal to 1 by a power n. Any negative powers that are there in your numerator can be pulled to the denominator to make their powers positive. So that is 2 over 3 x square power z power 7. And you know that any number raised to the power 1 is the number itself. So the final answer is going to be 2x square divided by 3yz power 7. That will be your final answer for problem number 26. Now let's go for the problem 27. Four x power 0, y power negative 2, z power 3 divided by 4x. 4x power 0, y power negative 2, z power 3 divided by 4x. Okay, so there are again multiple ways to solve this, but the first thing that you can immediately see and do is strike off the 4's, because they both are equal and they're in the numerator and denominator. The remaining term would be, you know that since 4 is not there, I'm going to not write 4, but x power 0 is nothing but 1. Any number raised to the power of 0 is 1. So remaining is y power negative 2, z power 3 divided by x. So again, we'll be using the formula which says a power negative n is equal to 1 by a power n, and you will be taking y power negative 2 to the denominator, and it becomes z cube y power 2x. So this is your final simplified answer. We are left with 3 more problems. 2h cube power negative 3 k power 4 divided by 3jk. 2h cube j power negative 2h cube j power negative 3 k power 4 divided by 3jk. 3jk. Interesting. So in the denominator, you don't have the h term, so you're going to leave it exactly like that. So let me rewrite this. It's going to become 2 over 3 h cube. I'm going to write it separately because this is going to be undisturbed. But you have j power negative 3 divided by j, k power 4 divided by k. Now You know that if there is no number or no power for a variable or for a constant, the default value is always 1. And then comes 2h cube over 3, and we are going to use the formula a power m divided by a power n is equal to a power m minus n. By using this formula, it becomes j power negative 3 minus 1, because power in the denominator is going to go up as per the formula, and you're going to subtract it from the existing number or existing exponent. The same way it becomes k power 4 minus 1. Now, if you see this, it becomes 2h cube by 3, and j power negative 3 minus 1 is nothing but negative 4, k power 3. All this remains in the numerator. But you know a power negative n is equal to 1 by a power n. That means this negative power can be pulled to the denominator, and it's going to be 2h cube k cube divided by 3j power 4 is your simplified form for the question. Okay, let us do 29. 4m power 4 n cube p cube, 4 power 4 m, sorry, n cubed or n power 3 p power 3. Any number with power 3 is also called as cube, that is p cube n cube divided by 3n square p power 4, 3m square n square p power 4. Thing have three different bases. Try to split them and try to write them separately. That makes your work very simple. So I'm going to write 4 over 3 m power 4 divided by m square, n power 3 divided by n square, p power 3 divided by p power 4. One simple formula that we're going to use is a power m divided by a power n is equal to a power m minus n. So this 4 over 3 m power 4 minus 2, n power 3 minus 2, p power 3 minus 4, 4 over 3 m square n p power negative 1. You know that a power negative n is equal to 1 by a power n. So this is the formula that we are going to use finally, and we are going to get m square n. P power negative 1 goes to the denominator, it becomes p power 1. But any number raised to the power of 1 is the number itself. So you're going to get this as your simplified form for question number 29. So now let us solve the last problem. Three x cube y power negative 1 z power negative 1. In the numerator we have 3x cube y power negative 1 z power negative 1. By seeing this only, tell y and z are going to the denominator to make them positive. You have x power negative 4 y power 0 z power 0, x power negative 4 y power 0 z power 0. You know that any number raised to the power of 1 is going to be 1. Any number raised to the power of 0 is going to be 1. So you don't have to worry about these two, because 1 multiplied by 1 is 1, and 1 multiplied by any number is the number itself. So to be 3x cube y power negative 1 z power negative 1 divided by x power negative 4. And I'm not going to write y power 0 as 1 or z power 0 as 1, because you know that they are multiplication identity. That means multiplying by 1 gives the number 7. But now I'm going to split this 3 x power 3 divided by x power negative 4 times y power negative 1 times z power negative 1. We have learnt a power negative n is equal to 1 by a power n. That is going to give you 3 power. And here we are going to, for this particular one, we are going to use another formula, that is a power m divided by a power n is equal to a power m minus n. It becomes 3 power x power 3 minus minus 4. And then becomes y power minus 1. Instead of writing y power minus 1, I can write this, I can move this to denominator, and I can write 1 by y power 1 multiplied by 1 by z power 1. So let us combine all the numerators after solving x. 3 minus of minus is plus, it becomes 3 plus 4 divided by y power 1 or z power 1. That 3x power 7 divided by yz is your final answer. With this, we are to complete this chapter, complete the laws of exponents. I hope you guys have understood, and you guys are going to practice all of these 30 questions along with, and there are many other sources out there, and I'll be putting a couple of links in the description for you guys to solve these kind of problems. But these 30 problems will actually give you a fairly simple idea of what this laws of exponents are. And if you can do all of these problems by yourself for the second time, for the third time, without referring to my notes or videos, that means you're good to go and you're good to learn the advanced concepts. Thank you. Thank you for staying tuned till the end of this video. I really appreciate it. And if you like our work, please do subscribe, share, and yeah, just save this to your playlist. And whenever you have any doubts, you guys can refer back and learn more from the same videos. And I'll be posting a lot of videos on different math concepts going further. So please don't forget to subscribe to our channel. Thank you.